In this video, we will be learning about ionic compounds with polyatomic ions and how to name them. The learning objective for this video continues our learning objective for learning how to name chemical compounds and write chemical formulas for them. So we talked about polyatomic ions in an earlier video. Polyatomic ions have many atoms, but they behave as one ion. And so it's really useful for us to just memorize the chemical formulas for these polyatomic ions and their names so that we can treat them as one ion and think of them as an extension to our periodic table. You should memorize your polyatomic ions because they will be used throughout the semester and you need to be fluent in them. Many of the polyatomic ions end with the suffix -ate, and we can help memorize their formulas by looking at the periodic table. So, for instance, this is boron, carbon, nitrogen, silicon, phosphorus, sulfur, chlorine, and so on. The polyatomic ions for these start with the base name of the chemical element and end with -ate. So bor-8 contains boron and oxygen. Carbonate contains both carbon and oxygen, and so on. All of the 8 polyatomic ions, 8 suffix polyatomic ions, have that first element along with oxygen. So other than that, we can look at patterns for how many oxygens there are by look at this subscript here. And so I've color-coded to help show you that most of these 8 ending polyatomic ions end with 3 oxygens. The only ones that end with 4 oxygens are in the center. And so if you can remember that the ones on the edges have 3 oxygens, and the ones in the center have 4 oxygens, you're off to a good start. The only central polyatomic ion that has 3 oxygens is silicate. And so I like to think of silicate and carbonate as a pair because they have the same charge and the same number of oxygens. And so I like to think of silicate as just like carbonate, only with silicon. And then that helps me remember silicate's chemical formula. Now, if I change color pens, we can talk about the charge on them. If you look at the charges for everything below the first row, everything in group 17 has a -1 charge. Everything in group 16 has a -2 charge. And then these ones have a -3 charge. Now, this top row here, if we imagine that those were shifted over because oxygen and fluorine are grayed out here. So really, this is the first one in this row. And so it has a -1 charge. And then this one has a -2 charge. And this one has a -3 charge. So the rightmost one has a -1 charge in all cases. So the rightmost one here has a -1, rightmost here has a -2, and these have a -3. You might also remember that sulfur has a common ion charge of 2-. And so everything in group 16 has a common ion charge of 2-, and the common ion charge of group 15 is 3-. You just have to realize that that 3- only applies to the phosphorus and arsenic because the nitrate is the first in its period, and so that's going to be a -1, not a -3. If it helps you, you can also remember that if it's an odd group number, then it has an odd charge. Even group numbers have even charges. So odd groups have odd charges, even groups have even charges. Hopefully those patterns help you memorize your polyatomic ions that end with 8 a little bit easier. You should get to the point where you can just look at the periodic table and imagine the chemical formula for the 8 polyatomic ions. From the 8s, we can modify the oxygen counts or substitute sulfur or add hydrogen ions to create additional polyatomic ions. Changing the oxygen count is based on the 8. And so if you have one more oxygen than 8, then it gets a per prefix. And so ClO3 is chlorate, and so ClO4 has one more oxygen than that, so it gets a per prefix, and it still has the 8. If you have one less oxygen than the 8 suffix, it now ends with ite, and one less than ite has a hypo prefix, and it still has the ite suffix. So there's a progression here. Now we'll talk about sulfur substitution. All of those oxygen-containing polyatomic ions have oxygen. Sulfur is in the same group as oxygen, and so sulfur can behave chemically like oxygen. And so any place that has oxygen bonded could have sulfur bonded in the same place. And so sulfur can replace one of the oxygens in our polyatomic ions. And if sulfur is doing that, then it gets a thio prefix. So for example, SO4, 2- is sulfate. SO3 has one less oxygen than sulfate, and so this one is named sulfite. Sulfite has 3 oxygens and 1 sulfur. This polyatomic ion has 2 sulfurs and 2 oxygens. So it's kind of like one of the oxygens became a sulfur. Sulfur is substituting for one of the oxygens. So now this is called thiosulfite. And so it gets the thio prefix in front of the sulfite to indicate that sulfur is substituting for one of the oxygens. For both oxygen count changes and sulfur substitutions, the charge is unchanged. And so whatever the charge was for the 8 polyatomic ion, that is the same charge it has, whether it has different numbers of oxygens or a sulfur substitution. Adding a hydrogen ion does change the charge though. And so if we add hydrogen ions to our polyatomic ion, we have to remember that it's not just adding a neutral H, it's adding an H with a positive charge. And so for every one H that we add, our charge is going to increase by 1. And so if you had a -3 ion and you add 1 hydrogen to it, then that's a +1 -3, so you're still going to end up with a 2- overall charge. If you have 2 hydrogens, then you're going to see this one had a 3- charge to it. Once you add 2 hydrogens, then that's going to go up to a -1 charge. So the charge is increasing, getting closer to 0. When we write our chemical formulas for ionic compounds containing polyatomic ions, our chemical formulas still need to be neutral, like in binary ionic compounds. So if we look at sodium and carbonate forming an ionic compound, sodium has a +1 charge, carbonate has a 2- charge, and so that means I'm going to need 2 sodiums for every 1 carbonate. And so I put a subscript 2 after the sodium. You can use your crisscross method to make sure that you get 2 sodiums for every 1 carbonate. Sodium with hypochlorite have a +1 and a -1, and so that adds up to 0 with just 1 of each, and so there's no subscripts needed there. Here we have calcium and carbonate. That's a 2+, that's a 2-, and so we just need 1 of each in order to add up to 0 and be neutral, and so we just write that as CaCO3. We're just putting the cation and the anion together. Now this is where things get a little bit different than in binary compounds. Calcium has a 2+ charge, but hypochlorite only has a -1 charge. And so we need to indicate that we need 2 hypochlorite ions. And so we have to put the hypochlorite in parentheses with a subscript on the outside to indicate that we have 2 hypochlorites. If we did not put the parentheses, then that 2 only applies to the oxygen, and it doesn't apply to the chlorine as well. And so if we wrote our chemical formula like this, it would look like we had calcium 2+ and some kind of chlorite ion with a 2- charge. And that just doesn't make sense because chlorite has a -1 charge. So we don't want to do that. We need parentheses to indicate that that 2 applies to both the chlorine and the oxygen. And so you can see in this diagram, we do have 2 chlorines total and 2 oxygens total. So that 2 has to be able to apply to both. So as soon as we introduce parentheses, some students like to put parentheses on everything. Really, we don't use parentheses very often. Parentheses are only for when you need more than 1 polyatomic ion, and that's it. If you just need 1 polyatomic ion, there's no parentheses at all. And so this is showing sodium with the chlorite ion, and so that's a +1, that's a -1, and so that's sodium with chlorite, 1 chlorite. If we need more than 1 polyatomic ion to make it neutral, that's when we use parentheses. And so that 2 applies to both the chlorine and the oxygen to represent what we have in our chemical formula. So that 2 on the outside applies to the whole polyatomic ion. Let's fill in the chemical formulas for this table, or work backwards to determine your cation and anion. Go ahead and pause the video and solve this in your notebook. Unpause the video when you are ready to continue. All right, let's go over this. So iron is the 3+ and chromate is a 2-. And so we will do our crisscrossing method to figure out our subscripts as a good starting point. That will tell us that we need 2 irons and we need 3 chromates in order to be neutral. That way we'll have an overall 6 positive charge and an overall 6 negative charge. Working backwards here, I can see that I see CO3. And so that's a polyatomic ion. And so my anion, CO3, carbonate always has a 2- charge to it. I have 2 sodiums. Sodium is in group 1, and so it has a common ion charge of +1. This is a polyatomic cation known as ammonium. If you know that NH3 is equal to ammonia, then NH4 plus is ammonium. It gets an EM suffix like sodium or lithium, which like to form +1 cations. And so we can just look at the charges. I will need one of each. And so I always write my cation first, followed by my anion. Do not merge the nitrogens just because they are both nitrogens. We have to keep our cation and our anion separate. When we're naming our polyatomic ionic compounds containing polyatomic ions, we will follow the same nomenclature rules that we did for our binary ionic compounds in regards to naming the cation first, followed by the anion. So we're still naming the cation first. And if we have a common ion charge, it's a type 1. And so we will not have any Roman numerals. If it's a type 2, then we will need Roman numerals to indicate the charge of the cation. And then when it comes time to naming the anion, we do not change the suffix. So no change to the polyatomic ion's name. So if it was chlorate, it's just called chlorate. If it's chlorite, it's just called chlorite. No "-ide" suffixes. All right. I'll give you this table as examples of polyatomic ion nomenclature. So let me decipher the chemical formulas for all of these. So the anion for the first one, I see Cr2O7 in the parentheses. And so I can look at my green reference sheet and see that that's called dichromate. And dichromate has a 2- charge to it. I could also uncross the subscripts in order to see that that was the charge. Iron here, if I uncross the subscript, then that is a 3 positive charge to it. That way, if I have 2 irons, it would add up to 6 positive, and 3 chlorides would add up to 6 negative. And so that would make a neutral ionic compound. Now I can name my compound. I first named the cation, which is iron, Roman numeral 3. Iron does not have a common ion charge, so I have to write the charge as Roman numeral. And then I write dichromate. For the next one here, I can see it's made with sodium and carbonate. This is the common ion charge for sodium. And so I do not need Roman numerals for the sodium. And so I'm just going to name this sodium. And then my anion is carbonate. So that's sodium carbonate. And so that would be Na I will need 2 sodiums to be neutral. And there we go. So for naming this last one here, I can see that that's ammonium. Ammonium has the chemical formula NH4+. Nitrite must have 1 less than 8. And so nitrate has 3 oxygens. So nitrite has to have 2 oxygens, but it would have the same charge. So then I can write the chemical formula. I would need 1 ammonium and 1 nitrite in order to be neutral. All right, here's a practice problem for you. Go ahead and pause the video and try to complete the table on your own in your notebook. Unpause the video when you are ready to continue. All right, let's go over this. All right, so I can always pick out my anion first and figure out the charge of the other things of the cation later. So that's tellurate. Tellurate has a 2- charge to it. Cadmium is part of that cool triangle in the middle of the periodic table that has a common ion charge of 2+. But even if we didn't realize that that had a common ion charge, we'd still be able to get its charge based on the fact that there's only one of it to cancel out the charge on the tellurate. Since it does have a common ion charge, I'm just going to name this cadmium tellurate. All right, for the next one, we have permanganate is the anion. Permanganate is MnO4 with a 1- charge. Calcium is Ca. Calcium is in group 2. Which has a common ion charge of 2+. So I will need 2 permanganate in this chemical formula. And so I will need 1 calcium, open parentheses, MnO4, close parentheses, 2. Now I can name this compound. Iron does not have a common ion charge, so I know I have to write iron with its charge in Roman numerals. And then this is hypobromite. As far as my chemical formula goes, I will need 2 hypobromites to cancel out the charge on my iron. Now I need gold 3+ hydroxide. My chemical formula will need 3 hydroxides, so I have to put that in parentheses.